Hi, this is Lori, and welcome to my series on the Pico W. In this episode, we're going to focus on how to format output in MicroPython. As I've done several projects with my Pico W, there have been times where I want to send some output to the shell or perhaps to write to a file to record some data, and it'd be nice to be able to format the output in exactly the way I want it to look. And as I have been learning MicroPython and the different ways to format, I realized that I didn't fully understand each of the different approaches. So I took this opportunity to do a deep dive and really understand how the different approaches work. In this episode, we'll cover using the string modulo operator, the format method, and f-strings. I've seen this quote before: there should be one, and preferably only one, obvious way to do it when it comes to accomplishing a task in Python. But as you saw in the introduction, there's several ways we can format output, but some are more preferred than others. But let's start at the beginning. The string modulo operator is the type of formatting that's been around in Python for the longest, I think from the very beginning. So it's the oldest approach, but from what I've been reading, it's not considered the best approach, and people suggest you not use this approach for formatting. But unfortunately, you'll see it around. It's there for backward compatibility, and because I think you see other people using it as you're learning coding from other people's code, you tend to pick up on it and continue to use it. So it has a life of its own. I've certainly used it in some of my own formatting and programming. So I don't think it's going away any day soon. And how it works is you have a string that you're going to format. You include some placeholders for the data you want to put into the string, and then you'll have a % and then a tuple that will contain the values that will be put into the placeholder. Next you'll see is there's a syntax for the placeholder here, the % flags with precision and type. And you can see a little bit more of a description down here about what each of those are. And here's an example of a placeholder for a floating point number. Here we'll say the %, and we want 6 places. You need to include a place for the decimal if you're going to have one in your output. And then the 2, you can see, refers to how many places after the decimal we'll have. So that's what that kind of a placeholder would do. I also noticed as I was playing around with the string modulo operator that if you specify a width and the item that you have is going to be wider, then Python will kind of just ignore your width and make it fit. So kind of fixes up foolish ideas that you might put into your code. And I have a couple of examples down here. Here's a print where we're going to print this string. And here's the modulo operator and the 3 values. The first is D, that's a type of integer. Then we're going to do the floating point for pi and some text, an S for text. So those are the types. And we'll just use the default setups for that and see what we get. And you can see here's the output for that print. Now, if I wanted a little more control over my pi, I could use something like this here. So instead, I'm going to make it 4 places wide with 2 places after the decimal as a floating point. And you can see I can kind of fix that up and make that look a little nicer. I just wanted to pause and say I got a lot of the information, and I did a lot of my learning on realpython.com and the pythoncourse.eu websites. Here's a couple of tables that just show the various flags we could use, and then also the different types that we have. So several of these types are also all integers. Floating point are things that people use a lot. If you want exponential notation, you can use these. So there's a lot of different approaches, and sometimes they make no difference at all switching between them, and occasionally they do. And we'll see a little bit more use of the string modulo operator in the demo we'll do next. Well, let's do a demo of some formatting, and we're going to start off first with the print function itself. There's some control we have over the output in the print function, so let's see what we get just using that. So I'm going to put a few variables in. for us to work with. An integer, a floating point, and a string. And let's look at the basic output of the print function for those. We can see that what we're going to get. Pretty simple, but certainly effective. Maybe you want a different kind of separator instead of just a space. How about a comma and a space? That might make the output look a little neater and tidier. Pretty nice. And the other thing that a lot of people do with the print is mix up some string with the variables, and we let the person know what these variables are. So let's just show how that works. Well, that's pretty useful, and in some cases that's kind of all you need. Next we'll mess around with the end argument. In this one we're going to loop through 0 to 10 and print it onto the screen, but we're not going to advance and get a new line. And let's see how that /r works. And this can be useful when you're getting sensor data and you don't want to fill up the screen with a lot of data. You just keep replacing the line. And you can see it's counting through the numbers here. Gets to 10 and stops. And that's a pretty useful function. Next we'll use the print with strings, and just a couple of string methods I thought I'd mention here are lower and uppercase. Let's just show what those would look like with the string variable we have. And you can see how those work. It's pretty useful to know those. There's lots of other methods, so you can do a lot to control how a string looks using some of those methods as well. Now we'll move on to using the Modulo operator. And the reason why you end up wanting to use it is you want to control maybe a little bit more finely how numbers come out. But there is still a function you can use within the print function that you can use to control rounding of numbers, and so the round function can be useful. Let's try that one. So let's round our floating point variable. And yeah, so that certainly works too. And now we're going to go ahead and use the string modulo operator, as we've discussed. So we'll print out the integer and the floating point and the string. And you can see there's our tuple of all three. And we'll go ahead and put that up. And there we go. Yeah, so that works fine. Now maybe we want to mess around with the numbers themselves. So here I'm going to print out the integer, but I'm going to treat it as a floating point with the one decimal place as a precision. And then we'll do the y the same way. So let's take a look at that. Notice I'm not specifying the width here. So we'll just let that kind of float, and Python automatically takes care of that for you. And then we could specify the width as well. And let's take a look at that. See how that looks. And there we go. Notice now we have some extra spaces here where we asked for 6, we didn't need 6, so it padded it with some spaces for us. And then here's our 6 that we used for the floating point. Next we'll take a look at exponential. So I made a new variable z, which maybe we'd want to show in an exponential format. So here's a couple different formats we could use for that, just to give you an idea of how that looks. And you can see you can either have the small lowercase e or the capital E, whichever you'd like. And last, it's always been useful to be able to control how binaries are printed out. And often I want to print them out as a string to the screen when I do things like binary counters and so forth. So here's a binary number, and I want to print it out so it doesn't have the 0b on it anymore. And one way I could do that is using the modulo operator, but then I'm going to use the bin function on my number, which is going to turn it into a string with still this 0b on it. And we can just take a look at that. Let's Let's see how that looks. So we'll put our binary number in, and then we'll just call this bin function on it and see how it looks. There you can see it's a string now, but it still has the 0B in the front. And if we wanted to take that off, then that's what this little piece is going to do. It's going to skip the first two positions in the string and start printing after that. And we'll print it as a string using the modulo S. So let's go ahead and put that in and see how it works. Oh, exactly what I would want. Our next approach is the format method. We'll provide a string template and we'll apply the format method to it. And we'll have replacement fields in our string, and we'll use either a positional reference or a keyword reference to what should be put into those replacement fields. And what we'll return back is a string formatted the way we asked. Here's a simple example. The first one we're going to use in our string is positional, the 0 place. And then under the format, you see the first one, the 0 position, is a 1. So it's going to put a 1 there. And then the 1 position, we'll put the 1 position here. We'll get the 2. And then I'm going to refer to a keyword of my text. And my text equals the string 3. And that's what's going to get printed out. Let's focus in on this naming of the source of the value that we want to format. As we said on the previous slide, we have either the positional or keyword references that we can use. And they come from this tuple that will be inside the format argument list. Now let's focus in on the conversion part of the format method. And you can use 3 different built-in functions to do the conversion. $S, $R, $A. As I was playing around, I found out $A is actually not available in MicroPython, but it certainly works in full Python. Sometimes it doesn't really make any difference which one you use, and the default is $S. So just a little information there about conversion. Now we're going to go to the format spec part of this, and that is actually, it can be broken down into several other items, and I have a table here which describes all of them. Just point out a few. We use the colon to indicate that here comes that part of the field, and we can discuss how we're going to fill the space if we ask for a width that's wider than our item will take. We can align it in different ways, left, right, centered. We can control whether signs show up. And then some things that we are kind of used to already, the width, a grouping variable. We'll talk about that in the demo. The precision, and then the type, like is it an integer or a floating point, that sort of thing. Just a little bit more on the type. You can see we can do binary, single characters, decimals, exponentials, floating points, octals, strings, hexadecimals, percentages. So there's a lot of types we can use with the format method. A little bit more about a couple of the subcomponents. Align is pretty useful. You can do left justified, right justified, centered, and you can also pad spaces for numerical values when a sign is included in the output, so that can be useful as well. And the sign one, we can also put a plus or a minus in to include the sign for positive and negative numbers, or only just for negative numbers, leaving some space for them. There you can see this is an example of where I've used the positive so that we can get the positive sign here on that format. And here's one with the equals so that we can pad the spaces. So it'll make sure all the spaces appear in between the positive sign and the number, which doesn't take up the full space. A little bit about the hash and the 0 subcomponents that are right here. For binary, octal, in hexadecimal, we can get an alternate form of the output using the hash sign, and when we put the 0, that'll pad the left with zeros. So here's some examples of the alternate formats of the number 13. And then here we're going ahead and padding the output so that we get more places. That was useful. That kind of thing is useful when we do binary counters, for example. The group subcomponent is kind of interesting too. It's just kind of a separator for numeric output. And you can use a comma or an underscore, but not in MicroPython. You cannot use the underscore, only the comma. And you can see here in my example, here's the comma, and so I want to format 1 million. I get my commas. But if I try to use the underscore for that, it tells me I can't find that. But if I do it in regular Python, you can see I could get a nice formatting of a binary number, for example, with underscores in between. So just another little bit of a difference when we're working in MicroPython rather than regular Python. A little demo to show off the format method a little more closely. Here I'll just use positional arguments in my string that I want to format, and I'll give the actual values inside the format argument list there. We'll take a look at that, see how that looks. There we go. And if I have the items to be put in as named variables, we could refer to them as their names. So let's try that way. We should get the same output doing it this way. Yep, so that works as well. And we could also name the arguments, so I could put them in to this list here of arguments, but I could actually name them inside the format argument list and do it that way as well. Certainly takes a little longer to do it. And now let's try some of the alignment, the align components. So the left justified, the right, and the centered. So I'll use all three of those here, and we'll take a look at how that looks. And print them out. And you can see the different justifications and how they work. And we can also use expressions inside of the format method as well. You can see here we'll do some calculation. We'll use one of the methods for strings here as well, and a length function. Let's try these out. And there we go. Yeah, it works perfectly. And last, let's just do a little formatting with binary numbers. So we'll pad this one to give it 8 places, even though it only has 6. And here we'll just see what it does when we just say, hey, take this decimal number and make it a binary, do the conversion to binary. I'll go ahead and check that out. Yeah, that's nice. And here we'll try those alternate formats as well, just to take a look at what they look like again. Yeah, we can have the 0b put in or not have it in there. So yeah, quite a bit we can do with the format method. That's a lot of methods to learn, and it's kind of good just to keep around those tables so you can remember all the options you have. Now, f-strings are the newest way to format. They were brought in Python 3.6. And from whatever I read, it seems like this is now the preferred approach to formatting. When we use them, they're pretty similar to the format method, and we use the curly braces, and we kind of create placeholders in our string. All the things that we learned from the format spec components that we just spent a lot of time talking about in the format method also work with f-strings. Thank you. And we can evaluate expressions inside our curly brackets, and they'll be displayed at runtime. And f-strings are faster than the modulo operator or the format method. And here's just a simple example of using the f-string. We start off with a lowercase f or an uppercase f. Then we give our string, and here's our curly brackets with what we want to format. So I've just put them right in here, and you can see in this case I gave the number and then said here's how I want it to be formatted, for example. So that's the kind of output we would get from f strings. Just a quick demo of the f strings, because we've covered a lot of the options and different kinds of methods that carry over from the format method that we can use in our f string formatting. We'll just show off a little bit and show how all those things we learned before are going to work pretty well. There we go. We can see our just basic output, as well as doing some formatting and justification and centering work pretty well. And we can also do Python expressions and various methods like we did with the format method as well. Slightly different syntax being used. And we'll see that all that works as well. Well, let's do an example that's maybe a little more practical, where we'll use the internal temperature sensor on our Pico and we'll control the output with f strings. Here's some code I put together to read the onboard temperature sensor on our Pico. It's on ADC4, and so we'll set that pin up and we'll read from it. And we'll use a couple of equations that you can find on the Raspberry Pi site for how to convert the readings into degrees Celsius. And I went ahead and converted that into Fahrenheit as well. And then I've included code to use all the different approaches that we've discussed in this video to output those temperatures to the screen. And we'll go ahead and use the f string where we do a little bit of formatting of our temperatures. And we'll make sure that we just continue to put that on a single line and not fill up the whole shell. Let's go ahead and run it. There we go. We can see the temperature, and every 2 seconds it's going to update. Let's see, if I put my finger on it, will I change the temperature a little bit? Yeah, just a little bit. Not too much. Well, that was a lot of fun. And thanks for joining me in learning about formatting output in MicroPython. I hope it was helpful for you, and thanks for joining me.